I just take some past year question like 2011 theory. 2011 theory, number 1. Why? 2011 theory, number 1. The question is, a stone projected horizontally from the top of the tour. A stone projected horizontally from the top of a tour. On the top of a tour. Top of a tour. Speed, at speed, 4 meters per second. Lands on the ground level 25 meters from the foot of the tour. Lands on the ground level 15 meters from the foot of the tour. From the foot of the tour. Of the tour. Calculate the height of the tour. G is, they say G is 10 meters per second. Find the height of the tour. Calculate the height of the tour. Calculate the height of the tour. Very simple. Solution. What do you have? Projected from the top. This is our tour. It's projected. It will go up and come down. We want to find the height of this tour. The height of the tour. The speed is 4 meters per second. We are given lands on the ground level 15 meters from the foot. That's the range. 15 meters. That's the range. So with R equals to UT, formula for range, 15 equals to velocity, I don't know. 4, sorry. R equals to UT, yes? Okay. Yes. R equals to UT. Okay, yes. At a speed, yes, this is the speed. Our U, yes, that's our 4. Our time, I don't know. 15 meters. I want to be sure. Projected 4 meters per second, horizontal distance of 25. It's 25, not 15. 24 meters from a tour. G is 10 meters per second square. 10 meters per second square. Let's confirm that our G is 10 meters per second square. Yes. 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 Our G, yes. From there, our T is 15 over 4. That will be 3.75. 483 in 30. 30, okay. Seconds. We have to find the height of the tour. The height of the tour. After knowing your T, our H here will be, don't forget, when you throw an object up, our height equals to half. Use this formula, GT square. Very important. Half G T 15 over 4 times 15 over 4. That will give you 225. 50 times 225 times 10. 2250 divided by 32. 2250. No. 2250 divided by 32. Half GT square. 2 here 5. Yes, that is 15 times 5. That is 225 times 5. Yes, divided by 16. Let's check any parameter missing. No parameter missing. I give you the range, the velocity, the t. We look for t. After knowing t, find the height of the tour. Let's be sure there's no parameter missing. Are we sure? Okay, there's a mistake. There is a mistake. We are using 15. The problem is from the question. The range here is 25 meters, not 15. R equals to UT. 25 equals to 4 times T. So our T is 25 over 4. So our height is half GT squared. Half G. 10 times 25 over 4 times 25 over 4. Yes. 2F5. That is 625 times 5 times 5 over 16. Yes. Because I should be able to know what the value is. As a scientist, when your answer is wrong or you have a mistake, you should be suspect. There should be suspect. Divided by 16. Correct. 195.3 meter. 0.3 meter. Yes, 2010. I have here 2010 number 1 theory, 2010 number 9 OBJ. 2010 number 1 theory, 2010 number 1 OBJ. Number 9 OBJ. The work 2009, 2010 number 9 OBJ. Number 9 OBJ. The question is, a body is projected horizontally from the top of a cliff 40 meters above the ground. 40 meters. 45 meters above the ground. Above the ground. If the body lands at the distance 30 meters from the foot of the tower, range 30 meters. Projected this way. Calculate the speed. Find u. Similar to that question. Only that in that question, we are given the height, the range, we are not given the height. Can you see the comparison? The one I did earlier, we are given the velocity, we are not given the height of the cliff. Here we are given the range and the height, no velocity. The same approach, the same method. R equals to UT. R range 30 equals to U, I don't know. T, I don't know. Very good. And you see that H equals to half GT squared. I've said it. H equals to half G 10 T squared. Are you follow? We are given the height, we are given this. Okay, what do we do? Parameters given. From our equation, V equals to U minus GT. Final velocity is 0. Okay, we are still looking for our T. Cannot 2 parameters. We are given the height. Our height, okay. We don't know time. We are given range. We are given height. Remember your formula again that S equals to UT plus half GT squared. Yes. G is 0. Yes. Half V squared equals to U squared plus 2AS. Very okay. Final velocity we are not giving. We are looking for this distance. Okay. Final velocity is 0. Our U. Our initial, this is U squared. Our 2. Our A, our G is 10. Our distance is 45. 45. Yes. Print this one here, we have, this is 415, 900. Is equals to u square, 2 times 10. That is 20, that will 900. U will be square root of 900. Velocity here will be 30 meter per second. We are given the distance. We are given the distance. Remember, that's why I use this formula. This formula we use to find the height. This is the formula. And when we use this formula, we say G equals to minus. And G is 10, distance is 45. I make U, the velocity, the subject of formula. So our option, 30 meters per second, correct option. The theory of the same year, 2010, number one theory. Number one theory. 2010, number 2009, number one theory. Tell me the 2009 theory number one. Number one. Is that 2009 or 2010? The speed is given at 2000. Determine the maximum height reached from the ground. It's projected with a speed of 2010. It's 2010. 2010 number. A stone projected with a speed of 30 meters per second from the top of a tower of height. The height of the tower is projected this way. The height of the tower is 50 meters. The velocity of projection, the velocity here is the velocity is 30 meters per second. Now find the maximum height reached from the ground. From here, easy. As it's come up from the maximum, from here to the ground, you are going to add the height reached here before coming down plus this height of the tower. You stay on top of the tower and you throw the height here plus the maximum height reached from the horizontal ground. You see, question say a stone projected vertically from upward with a speed of this from the top of a 1250 meter, determine the height of reach from the ground. For determine the height reach here, our v square equals to u square minus 2gs is going on. The v square equals to u square minus 2gs. So from here 2gs equals to u square minus v square. And our v square is 0. So 2 times g10 times distance equals to u square 30 square minus 0 square. From here our distance is equals to 900 over 20. That is 45 meters. You now add to the distance of 50 here. So the maximum height will be this h1 plus h. Height from here to here, h1, height from here to here, h. That will be 50 plus 45, 95 meters. That's the answer. No story. No story. 2000, I think, if you check other year, yes, the repetition. I've been looking at a question on bike. It's like we're repeating what we have been doing. This is 2007. 2007. Practice 2007 why? 2007 theory. 2007 theory number 1 and 1 and 2. Theory. Question says a particle is projected from ground with an angle theta 30 degree. 30 degree. Horizontal with a speed u is 250 meters per second. You know, say calculate the total time of flight. Total time of flight, that's language. T equals to 2u sin theta over g. Sin theta over g. The speed of the particle at its maximum height. The particle at its speed at its maximum height. Number 2, a stone projected horizontal from top of a tower with a speed this land on the ground 25 meters from the floor to calculate the height of the tower. We have done that also. So 2007, practice, have any question, let me know. We have done the number 1 question and number 2 question of that type. There's no need of repeating ourselves. This is WAEC 2004. I want to round it off on Projectlie. I have 1 question more. Let's say 1 or 2 question more on Projectlie. On Projectlie 2004. 2004 WAEC. There are one, let's start with number 2, because there are question 1 and 2. They draw a diagram. S, A, B, Z. The diagram, the diagram about illustrate the part ABC. A, B, where's my C? C. In the vertical SZ plane on a bullet shot into the air at an angle. There's a copy diagram using an arrow to indicate the relative magnitude and direction of the vertical and horizontal component of the velocity of the bullet at the point A, B, and C. That's all they want us to indicate. That's all. The directions. That's all. Number 1 of the same question. In his first attempt, a long jumper. Somebody want a long jumper. Somebody is jumping on a long jump. Take off with a speed of, number 1, 2004 theory, with a speed of 8 meters per second at angle 30 degrees. So there was no time. That's the first time. The second time, angle 45 degrees to the horizontal. Given that the expression for the range is, they even give us, thank God for this exam, for this YQ, they gave us the value of, for the range, the formula. We are all the symbol and their unit type. Show that if in the first attempt, this is the parameter. Second attempt, the same velocity, but at different angle, 45 degrees. We have to show that the body gain the distance of 0.8576 meter. Show that it gains this distance. Use your formula. You should be, when the person lifts himself at the first time at angle 30, the second time angle 30 at angle 45, it will move. The horizontal distance that it will cover will be more. Because the first lifting, he lifts himself at angle 30 degrees, the other one is at angle 45 degrees. The more the angle, the value, the range. Take notes. Those who are jumping on high jump, on long jump. So, the first attempt, arrow is equals to U square, A square times sine 2 times 60, 2 times 30 over G over 10. That wasting our time, 64 times sine 60 over 10. Our first range, R1, sine 60 times 64 divided by 10, 5.54. How many decimal places is that? 5.5426 meter. The second range, when you jump at angle 45 degrees, times sine 2 times 45 over 10. Arrow will be equals to, arrow 2 will be 64 times sine 45 is, sine 45 is times 2, that's sine 90. Sine 90 is 1, we know that. Sine 90 is 1 over 10. So the second range, arrow 2 will be 64 times sine 90, 64 times 1 over 10. That would be 6.4000 meter. So the difference between the first and second range will be 6.400 minus 5.5426. 6.40 minus 5.5426. That is 0.874. 0.8574 meter. This number should be 4 in the question. So correct. With this, we are through with Projectlie. I think this one is 2003. It's just a matter of story. 2003. Question says theory number 1. Take number 1. State 2 objects used in the sport and warfare, which may be considered as projectile. Sports. We have said that. Sports. Javelin. Shot put. That is discus. They throw it in sports. They follow a projectile motion. In warfare, catapult, your bow and arrow, your bullet. B said the horizontal range of projectile is given by arrow cost or use cost and 2 by you where is getting on. He now said, at what value would the range be maximum? Angle 45. That's the answer. Think with this. We are two with projectile motion that no begin working after German exam on your school. I've done justice. I think by now you should be loud. You should be laughing that this man has helped a lot to draw every curtain that is blocking our view on projectile. Draw them away. It has opened our eyes. So I thank you for listening. I want to go to another topic entirely. And let me take another topic entirely. And the topic I want to is still on motion. On our motion. At speed. Our equation of motion, our speed, our acceleration, our velocity time graph, the 4 equations of motion, and so on and so forth. So still on our motion, without wasting time, I want to explain what speed is, uniform speed, total speed, what velocity is, average velocity, total velocity, what acceleration is, uniform velocity, uniform acceleration, total acceleration. Speed is the rate of change. It is the rate of change. It's the rate of change of distance with respect to time. With respect to time taking. Rate of change of distance with respect to time. So speed equals to distance over time. That is the definition of speed. Rate of change of distance with respect to time taking. That's our speed. Speed is a scalar quantity. Speed is a scalar quantity. The graph of speed is distance moving with time. This is our distance in meter, our time in seconds. Look at this question in White-Necon and say that the slope of a graph, the slope of distance time graph is what? Distance time graph. Time graph is answer speed. Speed. You draw a graph of distance against time, the slope is speed. Take note, students. What is uniform speed? Speed is a scalar quantity, we have said that. What is uniform speed? A uniform speed, this is when the rate of change of distance with respect to time is constant. Look at the mathematics behind it. This is distance, this is time. This is distance, this is time. 2 meters, 1 second. Times 2, 8. Look at this variation. The distance on the vertical axis, the time on the horizontal axis. 1, 2, 3, 4, 5. 2, 4, 6, 8, 10. Student, listen. Distance in meter. This axis is distance in meter. And this is our time. Distance 2 times 1. Distance is 2. 4. 6 minus 2, 4. 4 over 2 is 2. So that is a uniform. So this is a uniform. Graph of uniform speed is this. Straight line. It's a straight line. Time in seconds. Distance in meter. Any graph like this is a uniform speed. Non-uniform speed. Non-uniform speed. Non-uniform speed is when the rate of change of distance with time, varies. Graph of this type is a non-uniform speed. Distance in meter, time in seconds. That is non-uniform speed graph. Total speed. Total speed. This is the total distance traveled. Total distance traveled divided by the total time taken. Total time taken. Study, student, study to confirm. To confirm. Now, thank you for staying with me. Thank you for being. I want to appreciate God for you. Thank you and God bless.